Now we're going to use all of the properties of logs that we've talked about to expand an expression and simplify. To expand means to use log properties to go from one log to many logs. The goal is to use those log properties as much as possible to rewrite all of the input of all of the logs so that the input has no powers, no products, and no fractions. Our first step will each time be to rewrite all radicals as exponents. Okay, so what does that mean? Let's remind ourselves of that fractional exponent rule. If you have something like the square root of x, we want to know what's the index on that radical and what is the power on the input. Once we have that, we're going to rewrite this as whatever's underneath that radical symbol, and we're going to write the power over the index. So it's power over index. Okay, if we had something like the cube root of x to the 5th power, we're going to rewrite that as x to the power of 5 divided by the index, which is 3. Alright, so the first step will be to rewrite all radicals as those fractional exponents. The next step is going to be a combination of both the product rules and the quotient rules. We're going to look inside of the fraction, and we're going to look to see what factors do we have in the top of that single fraction on the inside of that log. Factors are things that are separated by multiplication. So we're going to take all separate factors that are in the top of that fraction on the inside, and we're going to place them, we're going to stretch them out into a bunch of positive logs. So anything that's at the top of a fraction being multiplied together is going to go into its own separate positive log. What about the things that are at the bottom of the fraction? That's part of the quotient rule. Anything that's multiplied together in the bottom of a fraction is going to be written and separated out into a bunch of negative logs. All right. And then our last step is to use the power rule. Once we've used the quotient rule and the product rule to stretch it out into a bunch of logs, we're going to look at each individual log, and if all of the input is raised to the same power inside of a single log, then we're going to bring that power and multiply it out to the front of that log. All right. Okay, so let's look at our first example. We have log base 5 of, and we have a bunch of stuff going on the inside. We have a fraction, I see powers, I see radicals, I see things multiplied together, so we have a lot to accomplish. Our goal is to rewrite this so that the inputs don't have any products, no powers, and no fractions as much as we possibly can. Alright, so step 1 says if you see any radicals on the inside of this log, we're going to rewrite that radical using fractional exponents. So step 1. Alright, so at the top of this fraction I have the cube root of x squared plus 1. Everything underneath I'm going to put in parentheses, all in one big group, and I'm going to look at the power on that group, which in this case is an implied 1. So I'm going to convert this to x squared plus 1 as a group raised to the power of 1, and then the index, which is 3, is going to become the denominator of that fractional exponent. Alright, so the next step is to use the product and the quotient rules. It says to look at the top and see what things are being multiplied together in the top. So what separate factors do we have? Well, I only have one factor and there's nothing being multiplied times that. So that is going to go into a positive log. So now I'm going to stretch this out. I'm going to write log base 5, keep the same base. And I'm going to put that into a positive log, meaning that the log, the number in front or the sign in front of that log is going to be positive. Okay, so it's kind of like a quick product rule. Now the quotient rule says if you have things multiplied together in the bottom of that fraction, we're going to stretch those out also into logs of the same base, but in front of those logs I am going to put a minus sign. So anything that's multiplied together at the bottom goes into its own log of the same base, but we put a minus sign in front of those logs. Okay, so key there is that minus sign. Okay, so that's step 2. Step 3, we're going to use that power rule. And the power rule says that when you look into all the logs that we have now, do you have a log that has everything on the inside raised to the same power? And if you do, you're allowed to multiply that power out front of the log. So the first log says log base 5 of x squared plus 1 to the power of 1/3. Everything inside is being raised to the power of 1/3. Now what about the square? Can I bring that out to the front? And the answer is no, because the only thing that's being squared is the x. That square does not apply to everything inside. So we're not going to be able to take that one out. But I can take out the 1/3. So that becomes 1/3 times log base 5 of x squared plus 1. And the other logs don't have those powers, so I'm just going to copy down those two logs. Alright, so now we've used all three of those steps to rewrite the input so that there's no more products. So no things multiplied together. There's no quotients, in other words, no fractions. And there's not an input where everything inside is raised to the same power. So we've used our power rule, product rule, and quotient rule as much as we possibly can to expand. Okay, and so that's our final answer. Alright, in example B, the first thing we're going to do is we're going to take any radicals and we're going to rewrite them using fractional exponents. So at the top I have 5x squared, and I have the square root of 1 minus x. The index of that radical is 2. I'm going to put the whole group in parentheses and raise it to that power that's implied of 1. And so I'm going to rewrite this as 1 minus x in parentheses. We're going to put the power at the top of the fraction, and then we're going to put the index at the bottom of that fractional exponent. Alright, step 2 says anything that's at the top of the fraction that's being multiplied together can be put into their own separate positive logs. So we have 5 times x squared times that group. So each one of those is going to be broken up into their own positive log of the same base. So they're all going to get natural logs, or ln. Alright, now we'll move down to the bottom of the fraction. Anything that's multiplied together in the bottom of the fraction is going to go into its own separate log, but it's going to go into a log that has a minus sign in front of it. So still ln, but we're going to put a minus sign in front of those logs. So we have 4 times, so 4 is going to go into its own log, and then the x minus 1 squared is going to go into its own log. Alright, so everything at the top of the fraction went into a positive log. Everything at the bottom of the fraction that was multiplied together went into its own negative log. So we're going to pay attention to those signs that are out front of each one of those logs. So our last step, step 3, says that any log that has everything on the inside raised to exactly the same power, we're going to use the power rule to bring that power out to the front. So I have natural log of 5. There's nothing to do there with the power rule. But in the second log, everything inside is raised to the power of 2. So I'm going to multiply that 2 out front of that log. On the inside now I'm just left with x. For this log as well, everything inside is raised to the power of 1/2. So I'm going to multiply that out times the front of that log. That leaves us on the inside with just 1 minus x. The next log, there's nothing to bring out. So I'm just going to bring down that minus natural log of 4. For the last log, we have x minus 1, all of that input raised to the power of 2. So I'm going to multiply that 2 out to the front of the log. Now the negative is still there, okay, but the 2 comes in between the negative and the natural log, so it always gets multiplied and touches the L on that log. And left on the inside, I just have the x minus 1. So there is our final answer, expanded as much as possible using all of those log properties. Now we're going to look at example C. Example C has a couple of different ways that you can actually tackle this problem. The first thing I want to do is I want to think about step 1. Step 1 was to convert any radicals that you see into fractional exponents, and we don't have any radicals, so we don't have to worry about step 1. Step 2 would be to look at the product rule and the quotient rule. Okay, but there's something else that we can actually do in this case that I think will make the problem a little bit simpler. You'll notice that everything inside of this log is raised to the same power of 3. If that's the case at the beginning, then something we're allowed to do right up front is to go ahead and bring that power out to the front of the log. So let's look at that approach. Okay, once we bring that power out to the front of the log using that power rule, now I see that I still have a fraction on the inside and I'd like to get rid of that fraction. Okay, remember anything that's at the top is going to go into a positive log. Anything multiplied together at the bottom is going to go into a negative log. Alright, so we've expanded that as much as possible. Now the question is, what happens with that 3? Does it just sit in front of the first log? Well, no, it was 3 times all of that, so we want to be careful. If you bring your power out to the front and you have that log and you do any more expanding to the log that comes after it, then you really need to put parentheses or brackets or some sort of grouping symbol. Because officially what that means is that that 3 applies to both of those logs. So you can distribute the 3, if you wished, to both of those log terms. So that would be minus 3, and the numbers are always going to go in front of the L and in between the sign. Both of those are considered to be simplified and expanded as much as possible. Alright, so we've used our power rule and our product rule and our quotient rule to expand so that the inputs don't have any powers, there's no quotients, and there's no products. Now we're going to look at the opposite of expanding, which is called condensing. Condensing means to use all of your log properties to go from many logs to one log. The first thing that we're going to do is we're going to use that power rule. Now we're actually using the power rule sort of in reverse. We're going to look for any numbers that are out front of each log. Sometimes these are called the coefficients of the logs, but it's a number out front of the word log touching the L. Any value that's multiplied out front of a log, what we're going to do is we're going to take those and we're going to put them back on as powers on all of the input for that log. I like to leave any signs out front. So I'm not going to take the negative, I'm going to leave the negative, I'm only going to take the number as the power. So when we are condensing, that's always the first step that we're going to do. The second step is to use your product and quotient rules, and we're going to use them all at one time. Alright, so we are going to look at all of the logs, and we're going to look at which ones are positive logs, and we're going to look at which ones are negative logs. So anything inside of a positive log, so first here we have only one positive log, but anything that's inside of a positive log is going to go into the top of the fraction when we condense it all down into one log. So we're going to condense all of it down into one log, and anything in a positive log is going to get multiplied together at the top of that fraction inside. Alright, so anything inside of a negative log, so we're going to look at the sign out front, and we're going to take the inputs that are in those negative logs, and be careful here, watch what happens when I put them underneath. They're going to go together underneath the bottom of that fraction, and they're going to get multiplied together. So really important there, they get glued together on the inside by multiplication, not addition, not subtraction, but by multiplication. So we're going to multiply that times the input from the other negative log. Alright, so anything in a positive log gets multiplied together at the top of that fraction inside of that single log, all the inputs in negative logs get multiplied together at the bottom of that fraction of that single log. Alright, the last thing is an optional step. I do not require it, but you could take any fractional exponents and then convert them back to radicals. So that's optional. If you stopped right here, I am happy with that. I am fine. If you choose to go further, then that is fine as well. Both would be 100% correct. So you would have square root. So the denominator would become the index of a radical, and the power would be what goes on top. Now when you do that, typically we do not write the index of 2. We usually leave that as implied, and of course we don't usually write something to the power of 1. We usually leave that as something implied. So if you do convert that back to a radical, that is fine, and that is completely correct. So either one of those two could be your final answer.